So in this lecture, we're going to continue our discussion of functions by looking at how we can find the domain of a function. And more specifically, we're going to be looking at how you can find the maximum domain of a function given a formula that represents it. So when we do this, there are two things that you need to be aware of. Right? You need to be on the lookout for even roots, because remember, you can't take the square root of a negative number. You can't take an even root of a negative number. And you need to be on the lookout for variables in the denominator, because you can't divide by 0. So what we're going to be doing here is we're going to start with the assumption that the domain of our function is all real numbers, right? Because we're only going to be talking about real valued functions here. Then we're going to take away things that cause problems. We're going to exclude any numbers that make the expression under a square root negative, and we're going to remove any numbers that make our denominator 0, and what's left will be that maximal domain. All right, so we've got an example here, right? And we've got a function, f of x equals the square root of 3x plus 2, and I want to find the domain of this thing. Right, well, I've got an even root in here, right? And I know with even roots, I have to be concerned. I can't let x have a value like -5, for example. If you put -5 in there for x, that becomes the square root of -13, and we can't do that. No complex numbers allowed, no even roots of negative numbers. So how am I going to find this domain? Well, my requirement here is that that thing under the square root has to be greater than or equal to 0. Right, so when is that true? Well, let's solve this. 3x greater than or equal to -2. X is greater than or equal to -2/3. So those are, in a sense, my good numbers. I can put any number greater than or equal to -2/3 into that function for x, and I get a real number back out. Right? So this is going to be my domain. But how do we write this? Okay, well, we can write this two different ways, right? We can write this using the so-called set builder notation, where I would say the domain, let's say D, the domain, equals the set of all real numbers such that x is greater than or equal to -2/3. All right, that's one way. Or I could do this using the interval notation. I would say we're going to do everything greater than -2/3, including -2/3. That's why I use the square bracket here instead of parentheses, up to plus infinity. Oh, I left out let me squeeze it in here. D equals, right? That would be the domain of this function. And this is the general case, right? Anytime you have something with a square root in it, right? To find the domain, I'm going to take whatever it is that's under that even root, make it greater than or equal to 0, solve that inequality, and I'll have my domain. All right, so how about this guy? Right, what is the domain of this function? Well, there's no even roots here. That's good. But there are variables in the denominator. So I know that I have to exclude any number that makes the denominator equal to 0. So I'm going to say, when is x squared plus 3x equal to 0? And what I want you to keep in mind, because this is kind of the reverse of what we did before. Here, we're not finding the good numbers. We're finding the bad numbers. Or we're finding the numbers that are not in the domain. So if I solve this, I'm going to factor. This is x times x plus 3. And we get two solutions, right? X equals 0 from the first factor, and x equals -3 from the second factor. So those are the numbers that are not in my domain. So again, how would we write this? Well, using the set builder notation, I would say the domain is all real numbers such that x is not equal to -3 or 0. Okay, now how would you do this using the interval? Sorry, another way I might write this. I might also say it's all real numbers minus -3 and 0. In fact, that's the one I usually use because it's kind of the most compact. It's the shortest of all of them. How would we do this using the interval notation? Well, let's look at this visual here. Right? Let's say I try to graph this. Let's see what this looks like. I've got -3 and 0, and I don't want to include those numbers, but everything else is fair. So from the interval notation perspective, my domain is made up of 3 intervals: this one, and this one. So using the interval notation, I would say my domain is -infinity to -3, union -3 to 0, union 0 to plus infinity. That is my least favorite of the 3. Okay, because it's very long-winded, and I don't even think it's a very good way to write it, just in terms of what does it mean, right? If I look at my favorite method here, I can tell really quickly what I'm talking about. It's all real numbers except for those 2. It takes a little more processing mentally for me to get that same kind of straightforward description out of this interval notation. All right, so I've got another one here, and this one combines the 2 situations. We have both an even root and we have variables in the denominator. All right, so we're just going to use both methods, right? I'm going to do the even root part first. I know that this thing under the square root has to be greater than or equal to 0, which means x has to be greater than or equal to -2. All right, so let's get another graph going here, right? So far, there's -2. Everything from there up. Whoops, I changed my color. Sorry about that. Everything from there up is part of the domain. All right, so now let's think about the variables in the denominator bit. This thing in the denominator can't be 0. So now I'm going to go write it that way. I'm going to say this is not equal to 0, right? So now, well, let's solve this. If we square both sides, x plus 2 is not equal to 0 squared, which is 0. So x cannot be equal to -2. Okay, so let me modify my diagram down here to reflect that. Right now, I'm going to replace that filled in circle with an open circle. And that's it. I looked at both of the cases that I have to think about, right? And that's my domain, right? It's a visual representation of my domain. So I would say either the domain is all real numbers except -2, or if I wanted to do this using the interval notation, I would do open parentheses, right? Because I don't want to include 2 up to positive infinity. Both of those mean the same thing. All right, so where are we going next? Now that we've seen where functions, how to determine where a function is undefined, right? The function is defined on the domain and it's undefined everywhere else. In the next couple of lectures, we're gonna talk about how you can get information about a function in 2 ways. First, we're going to do it by looking at a graph of the function, and then we're going to do it by looking at the formula that represents the function.